Hi, everyone. My name is Caroline Guo, and I'll be helping facilitate today's webinar. Thank you all for standing by, and welcome to our webinar, Fully Managed Service Networking with HCS on Azure. In today's webinar, we'll be walking through Consul's service discovery and service mesh features within your Kubernetes or VM-based applications. Our demo today will provide an overview of the latest release of HashiCorp Consul service, which is HCS on Azure. This allows your team to provision HashiCorp managed Consul clusters directly through our Azure Marketplace. During the webinar, please feel free to type your questions into the Q&A box. Please be sure to type them into the Q&A and not the chat box if you'd like us to address and answer them. This webinar will be recorded, and the recording will be made available to all the folks that have registered within a couple days after post-processing. Our speakers today are Alex Josh, Product Manager at HashiCorp, and Eric Veld, Developer Advocate at HashiCorp. And with that, I'd like to pass it over to Alex to kick us off.
Awesome, thanks. Hey everybody, my name is Alex Josh. I'm Product Manager for the HCS service. So thank you very much for joining us. We always love these sessions, and we appreciate taking time out of your day. So we're going to talk about microservices generally, but very specifically in the context of what we refer to as HCS or HashiCorp Consul service. The intent here is that I'll kind of walk through what HCS is, how it's going to work, and then I'm going to hand it over to Eric, and he's going to get into much more of the how do you use it part of the conversation. So just a really quick overview of what Consul is. Hopefully most of you have already seen Consul, so this will be a little bit of a review, but for those of you that are new to this world, we'll just do a quick 10,000-foot view of what Consul is, what it's about, what it's for. So, the most important thing to think about when you're thinking about Consul is to think about the transition that we're all making in our infrastructures. So there's a really interesting and long history about the way that large infrastructures have been built over time. Sometimes it's referred to as monoliths to microservices. I prefer to think about this as the natural evolution of our applications as we move into cloud and as we become more velocity friendly or more focused on velocity in our application space. So many moons ago, when we wanted to deploy infrastructure, the way we normally would do it is through a series of servers. And in fact, it used to be the case that servers had very specific names and specific purposes. I'm old enough to remember the day when we had a set of services in my organization that were named after planets because we only had 6 of them. Today, that's not going to work because now you have hundreds or thousands of objects. But back in the day, having 6 whole servers in your data center was quite a few. So over time, what's happened is that this infrastructure has grown and grown and grown as things become more complicated. And so over time, what happened was then, of course, we moved to virtual machines. VMs were the standard pattern for deploying applications, especially for enterprise, for a long time. And this is a very useful pattern. I'm a former VMware employee, so using VMs on vSphere was very common. We had lots of customers doing this work. And what's happening now is that as systems continue to evolve, that infrastructure has now become less desirable, mostly because what's happening is that the complexity of the applications are going up. And there's new techniques like containerization and things like that, which allow us to break things down, break applications down into smaller and smaller pieces, or that is to say, microservices. And there's actually 2 trends that are kind of coming together at the same time. One is this debate about what's sometimes referred to as pets versus cattle, and the other one is containerization. So if you think about your infrastructure as this, temporary collection of server objects that come and go over time, and they're basically ephemeral, and then you add to that the idea that says, well, what we're really going to do is we're going to have lots and lots and lots of these very small applications, these very small services that are also ephemeral. Then you start thinking about that's a much more dynamic and complex environment than we were building even 4 or 5 years ago. It used to be the case that you would provision networks statically, that you would say, okay, I have 3 production networks. Network 1 is where my databases live, and network 2 is where my app tier lives, or something like that. Or I might say, I'm going to put all 3 tiers of my application into this single /24 network. and everything lives in there, and I'm going to provision there. I've even had customers do things like hard code IP addresses into their applications because they knew that their network infrastructure was super static and it was never going to change. Clearly, that's not probably what we want to shoot for in the cloud. We want a much more dynamic environment. We have lots of objects. Those objects move around. They come into existence. They go away. You know, whether it's time of day scaling, like for example, in the morning, we know that 1,000 employees are going to come in and log into the site. So we want to scale it up a little bit. But then by 10 o'clock, that activity is done. Maybe we scale back down. Maybe we don't need those many objects. Or we could have seasonal availability. You know, during Christmas time, my storefront needs to be much larger than it needs to be in the middle of the summer. All these kinds of things leads us to prefer these types of more flexible architectures. So in that context, then, if you think about the difference between the static infrastructure and the static networking that we used before, which was, you know, completely acceptable, worked fine, was not ever a problem. Now you're starting, there's this disconnect now, because now the objects that I'm managing, the hosts, the servers, the containers are becoming extremely dynamic. So the assumption is that my networking infrastructure should be dynamic as well. And traditional networking approaches kind of struggle with that. How do I find this object? Where is it exactly? What's its IP address? How do I make sure that the right ports are open? How many of these objects do I have registered? So we started off with very simple, like, well, why don't I just go into this system and I'll just declare the fact that I'm hosting this service and what my IP address is. So you start off with like a very simple KV store, which is where Consul started. But then after a while, I was like, well, I really want to talk to that service. I don't want to just know where it is. I want to talk to it. I want to have a secure connection to it. So you wind up with this parallel process that says, well, I have to discover and connect. And so the idea with Consul is to bring those two concepts together and just say, okay, I want to discover this service, but then I also want to talk to it in a secure manner. And I don't want to worry about networking. I don't worry about routes. I don't want to worry about ACLs. I just want to say object one can talk to object two. And as long as we have the correct permissions, we can talk. And how the network looks and where we're living, and maybe we're not even in the same data center, that shouldn't matter. I want somebody else to handle that for me. And that's really Consul's mission in life, is to make that much easier to use. And so the idea here is that Consul provides this service discovery functionality so that you can figure out where the things are, segmentation to make sure they're really secure, that object one is allowed to talk to object two, but not object three. And that is built into the way Consul works. And so we declare your services. You're basically saying, you're also creating, in effect, these kind of business rules or these security rules that say what objects are allowed to talk to what. And you don't have to worry anymore about service one accidentally impinging on service three, right? Because you're registering and you're talking to the correct service. And then, you know, of course, Consul also has this notion of connectivity, or what's called Consul Connect. And then that is what forms this network connection between the two objects. And that's done securely inside of the tunnel, all those kinds of good things, as you expect. So what is Consul for? So really it's three things, right? It's service discovery. And this is done via DNS and HTTP. So you can do something like, hey, I am the billing service, right? So you register, you declare yourself, you're, a container running in a Kubernetes cluster or just running by itself. It goes to Consul and it declares, it says, I am this object of this class, and I am implementing this service. And so you can go and say, oh, great, I want to hit, billing.myapp.mycompany.com, and you get back an IP address and you say, oh, good, that's my guy. I'm going to go talk to this object. But then once you do that, you can then also use Consul Connect to then actually deliver that connection. Instead of setting up a route or opening up an ACL or doing anything like that, you just say, okay, now I'm going to go talk to them. And we'll just push the bits across from service one to service two, even if they're running on different machines, even if they're running in potentially different data centers, even via federation. And then the final one is service configuration, which is kind of where Consul gets its roots, is this notion of a key value store. There's plenty of people that use Consul just as a key value store, which is fantastic. But there's this broader use case that we're really focused on. So think of key value store as the foundation upon which all this other stuff sits, right? You can't do service discovery or service mesh unless you have service configuration, because you need to be able to look these things up, right? What is the IP address of my billing service? Well, that's a value stored in a key. And so those things, those two use cases support each other, and they're built on top of each other. So that takes us to HashiCorp Consul service. You might also hear me say HCS during the talk. So we refer to this as HCS. So what's interesting about HCS is that HCS came from customers telling us that as they move into cloud, they may not be interested in running their own infrastructure. You know, one of the decisions you make when you go to cloud is how much control over the infrastructure do you wish to have? We have a lot of customers who are saying to us, hey, what I really want to do is I want to run Consul inside of my AWS account, and I want to manage the Consul installation, which absolutely works just fine. We fully support that. We have a lot of customers doing that, whether it's on GCP or AWS or Azure today. It already works. But there are some customers who say, you know what, I like Consul, but what I really prefer to do is I really prefer you folks to manage the infrastructure for me. In the cloud, I don't want to manage my databases, I don't want to manage my routers, and I don't want to manage my Consul either. And so that's what HCS is about for those customers who don't wish to manage the infrastructure on their own. So if you think about what is Consul as a service, well, fundamentally, it's Consul. So the things we already talked about, service discovery, key value pair, things like that, those are all in the core Consul bits. And what we're doing is we're delivering Consul, the Consul you hopefully already are aware of, in a managed service offering. So the delivery vehicle and the way you operate Consul is different, but the use cases are the same, the way Consul works is the same, and in fact, the northbound API, the way you consume Consul, is exactly the same. Use the same client, use the same API. What you don't do is you don't install it, you don't administrate it, you don't operate it, you don't patch it. Those are all things that we provide to you as a service, as you would expect. So similar to the way you would consume Kubernetes through AKS as a service from Azure, you would consume Consul through HCS as a service, but it just happens to be from us instead of from Microsoft. This is a fully managed service. It's sold, supported, and managed by HashiCorp employees 24/7. We have a global team that provides us this service. And we are responsible for things like uptime. If there is a problem, if we take an outage, if a server dies, these are all HashiCorp employees that will respond to that. We get the page, we're on pager duty, we're on call 24/7 to make that work. In the case of HCS, the billing comes to you through Microsoft because it's a marketplace application. So you would consume it through Marketplace, which I'm going to show you in a few minutes. You receive your bill from Microsoft, just like you would from any other Azure service, but the actual backend, the actual operations is all operated by HashiCorp. It allows you to build a service discovery and service mesh service on Azure. The intent is to provide as native of an Azure experience as possible. So if you are an existing Azure user, hopefully HCS looks and feels and smells like you would expect an Azure service to look. Now, naturally, there's Consul-isms, and there's places where you can consume Consul directly, and we'll show you that during the demo portion of the talk today. So what happens is that we are responsible for provisioning and managing. We will, once you tell us to do so, we will set up the VMs, we will put the Consul bits on them, and then afterwards we will manage them and make sure the version is correct. You have direct control over access. So just like any other Azure object, you use Active Directory in Azure to control access to the Consul clusters. And then you will receive metering and usage on your Azure bill. So what does this look like? This is a very high level diagram. This is not meant to be a deep dive architecture discussion, but at a super high level, what happens is that that you go into Azure portal, you provision a VNet in Azure the way you normally would, and then you go to Marketplace and you provision a Consul cluster from Azure Marketplace. Under the covers, what's actually happening is Azure calls our API and gives us a secure token and says, okay, this user on this subscription ID and this account wants to consume Consul now. And we then have the ability to create what's called a managed resource group. And that managed resource group receives the virtual machines and the network and the storage account that Consul needs to run. So when we're done, what will happen is you'll have two resource groups now. You'll have a customer resource group, which is the one you started with, right? That's the one you own. We have no access to it. And then there's a managed resource group, which is jointly accessed. So you can see it. It's referenced in the portal, in the Azure portal. But we have the ability to do things like add or remove virtual machines, start or stop instances, apply IP addresses. And the reason why we need to do that is because that allows us to do things like patching Consul to a new version. So there's this shared administrative model, the shared responsibility model. And so that square there in the lower left is where that common area of administration overlaps. So that top square that says customer resource group, that's completely your responsibility. On the far right of your screen where it says HashiCorp, that's completely our responsibility. And then they merge into the shared resource, into this what we call managed resource group. And I'll show you this in the UI in just a moment. So we're going to show you a quick demo. Unfortunately, HCS provisioning takes about 15 to 20 minutes. So I can't show you the whole flow live. So we're going to do the cooking show technique where we're going to show you how to bake a cake, and then magically the cake will just be ready in 10 seconds. So I have a pre-recorded version just for reference. But don't worry, this is all live. I'll show you all this working in the UI in a moment. So here we go. So this is pre-recorded. So what you're going to see is that in the marketplace, you just go and you search for Consul. And when you go in there, what you'll see is there's actually a container image from Bitnami, right, which is awesome. That's for yourself. If you want to use managed service, then you go to Consul service on Azure. And when you do so, then we'll ask you a couple of basic questions, like your subscription ID. As you can tell, I'm borrowing one from the Nomad guys. Don't tell them. And then you have to make a decision about whether you want a production or non-production cluster. The difference is non-production clusters are cheaper. They only have one host, but they don't have any SLA, and they're not redundant. So for the demo, we're going to go ahead and choose a full production cluster. You have to give it a name. Doesn't matter what this name is, but this is the name that'll show up in the Azure UI. The underlying cluster also has to have a name. Again, this is an Azure name, so you give it to that. And then the data center within Consul has a name as well. I'm just going to leave the default. And then the most important things here are the disabled versus enabled external endpoint. What that means is whether or not you have a public IP for this cluster. Now, for the purposes of demo, I'll go ahead and say enabled. But if you're running a production environment, you probably want to say disabled. And you'll notice that was the default. And then we say create. Now, this is the part of the process that takes about 15, 20 minutes. So I'm going to stop the automated the recording here because I did this earlier. And so if you go into Azure portal, what you'll see is, so here's my environment, and I have my own resource group. And inside this resource group, I have a bunch of objects I've created to help me test my environment, including a VM and such like that. But the things here that really matter are we have this Consul test virtual network, and we have the managed application itself. For the virtual network, I'll just point out that this virtual network is actually peered. And the reason why that matters is because that's what allows us to communicate with the underlying Consul network that got created, right? And you'll see here that it's been listed here. So there is one additional step that I took prior to showing you the environment, which is to peer my VNet with the VNet that's created in the managed resource group. Let me just show you that right quick. So here is the managed application. And you'll notice that it has a managed resource group. So remember in the prior diagram, I showed you that there's two resource groups, the one that I own, that is to say Cloud PM Test, and the one that HashiCorp owns, that is to say this managed HCS production. So just note that. Inside of this object, what you'll see is we have access to the Consul UI. And this is exactly the same Consul UI that you would see on-prem. But we also have this thing called the Consul clusters. And the reason why I bring this up is because there's some very useful information in this cluster object, and specifically down here in properties. So when I click down into properties, there's some really nice things like, for example, private endpoint URL. So the way this works is that when we deploy the cluster, we have two sets of IPs. We have a public IP, that is to say externally visible from the internet, which is enabled or disabled, depending on the settings you made in the setup screen. And then we have a private IP. This is the CIDR range that you delegated to us. 90% of the time when you're running Consul in production, you're always going to be talking to those private addresses. And those private addresses are accessed right here in this URI. So if you ever want to go and ping them or hit them directly, you don't want to hit a specific server, you can go grab this. And this is probably the fastest way to go make sure the Consul's up and running is you can grab this URI, you can ping it, it'll resolve to an IP address, and you'll see in your environment. All the other properties we set here are earlier here as well. So here's my version that I set, things like that. Also, you'll see external endpoint is enabled in this case. That's because this is a demo. Again, in production, you may or may not want to do that. Okay, so that's the basics of how a Consul service works. And now I'm going to hand it over to Eric, and he's going to get into the really good part, what you can do with it, and kind of walk us through a scenario. Eric, it's all yours, sir.
Really quick, before we, no worries. Before we pass it over to Eric, I'm going to launch a poll for the audience so we can get a better understanding from the audience what your background level is with HCS on Azure, Consul in production, and AKS and VMs, as well as a request for follow-up from sales. So I will launch this now.
While we're doing that, you want me to answer a couple of the QA questions, or are we going to leave those to the end?
Yeah, let's do that. That's a great idea.
Because the first one's really easy to answer. I can get that one.
Sure. So the first question asked was, why is VNet peering and not private link? Are there protocol dependencies, except, for example, UDP?
Yeah, and the answer is, as you expected, this is a protocol thing. So the way Consul works is that all the nodes need to be able to see each other all the time. And this is because of the way that Gossip works, which is the underlying protocol. So we haven't been able to make this work with private link at the moment, because private link assumes that you're sitting behind sorry, my mind just skipped, behind a load balancer. And so not all of the hosts are directly visible to all of the clients. So at the moment, we're supporting VNet peering only. Private link is definitely interesting, and it's something that we would like to support, but it's not in the current version of the product.
Great, and then let's cover one more question, and then the rest we can do at the end of our session. So there's a question from Stefan asking, can HCS also run on AKS instead of on VMs and still be managed by HashiCorp? Similar to the MS default deployments like the tunnel or OMS agent. Thanks.
Yeah, a similar kind of answer. At the moment, Consul itself runs in VMs. And the reason why we've chosen to deploy it that way is because this is the way the Azure Marketplace works. Azure Marketplace does not allow us to sell containers on your AKS cluster. As you can imagine, that would be a little dicey because that would require us to be administrators on your cluster. Maybe not what you want. So this current model gives us some good separation of powers and isolates us into a separate dedicated resource group. Of course, Consul itself can run in a Kubernetes cluster if you wish to do so, but this particular service is implemented on VMs. Now the clients, the guests, obviously can run inside of AKS just fine. It's just that the Consul servers themselves are running in VMs in this case.
Okay, great. Thank you. We've wrapped up the poll section and we can pass it over to Eric to take us through the second part of our webinar.
All right, let me share my screen. There we go. I hope that's all good and visible. So yeah, I will be taking the setup that Alex has just showed you, and I'm going to show you how we can use Consul to migrate applications, monolithic applications from VMs to running on Kubernetes as microservices. So I'm going to do everything live and manual, so bear with me. And I'm just to speed things up, I'm going to simulate a lot of things locally, and I'm going to use a tool called Shipyard for that, which will actually make it possible for you to afterwards take the Git repository and try everything for yourself. So where we're going to start off is we're going to have an AKS cluster, and we're going to have a Consul cluster, and we will have our monolithic application. So in this case, it's called the payments application, and it's fronted by a proxy called web. And these will be running on VMs. And where we want to move to is where all these applications are running on AKS and actually split it up into microservices. So for demonstration purposes, we have the payment service, which currently has a currency service built in that it calls. And we're going to be splitting that up and make that an RPC call instead. And we're going to be using HCS to do all the service discovery for us. So as I said, we're going to be simulating some things, and just so things spin up very quickly and they don't use too many resources, I will be simulating VMs with fat containers. So these containers will contain a supervisor, a console client, the application, and then an Envoy sidecar proxy. But that will then all be running inside a container. So let's start off with the application and the state we want to move to, right? Which is using the service mesh to communicate. So if I switch to here, let's first spin up the environment. So let me create our cloud environment and let me explain what that contains. So if we look here, we have two networks. We have the WAN network for internet connectivity, and we have our private network, which could be a on-premise data center, or in this case, represents Azure Cloud. And then next to that, what we're going to be spinning up is a Kubernetes cluster. So in this case, it'll be running on K3s, nice and lightweight. We're going to connect it to both of the networks, both Azure and WAN. And then I'm going to be spinning up the Consul Helm chart on top of that. So I actually have a Consul client running on the machine that talks to an external Consul cluster. So in this case, I'm just running Consul as a separate process outside of the AKS cluster, just like HCS would be running. And it's also connected to both of the networks, so they can actually communicate to each other. And it's basically just running the vanilla Consul container with some configuration. Now, if we look at the Helm chart, and let me just make this a little bit bigger, we see that I'm only running the client as a pod on Kubernetes. And what I've done to enable service mesh is I've set gRPC to be true. I'm joining the Consul cluster that's running externally, and I've enabled connect inject. So that means that if we launch a deployment, we can actually specify that we want a Envoy sidecar automatically injected into our pod to do all the routing for us. And then lastly, I'm enabling the central config, so we can use the central configuration to do L7 routing for us later. Now the environment has spun up. As you can see, we've created the AKS cluster, we've spun up HCS, and everything is healthy, and then we've created the Helm chart. Now, to interact with the cluster, let me just run shipyard env, so we can actually do kubectl get pods, so we can see that, okay, Consul is actually running, and we have the injector running beside it as well. And then let me open up an extra browser tab here and drag that in. We can see that the Consul UI was opened as well, and we only have Consul running right now. So what we need to do now is we need to go to the initial situation where we actually have the applications running. So what we're going to be starting off with is two of those fat containers. And I'm running an application called Fake Service, which is a demo application I like to use because it actually shows you the trace of all the points that are being touched. So here we have web, which is the proxy, and we're giving it a static IP address, and it'll just respond eventually. And it's calling an upstream of 10.5.0.110 on port 9090. And that is where the payment service will be running, right? So we also allocate that an IP. So if we run this, I can again use the shipyard run command to spin that up. And it's starting the first container, the second one, and then opening it up for me in the browser. So here we see Fake Service in action. And we can see that we're calling web on 10.5.0.100, which then calls the upstream of 10.5.0.110 on port 9090. So these calls are static, and as you can see, we get different durations. So the calls actually succeed, but everything is static. So if we move the payment service, the call will break because it's no longer reachable on that IP address. So where we want it to move to is to this situation where we have web, which has a sidecar proxy listening on localhost that actually forwards the request from the local sidecar proxy to the sidecar proxy on the other end where payments is running. And in this case, it won't matter anymore where these applications are running because the sidecar proxy uses the service discovery from Consul to actually populate its upstreams and its listeners. So we can actually use that service discovery to route the request to the right location, right? So in order to do this, we will first need to register these two services into Consul Service Discovery and then make sure that they have a sidecar proxy. Now, the web service is actually a very simple proxy, like an Nginx or an HA proxy, and those are very easily containerized. So we can already start moving that to Kubernetes. But the payment service is a big monolithic application, which will take some time to actually break up and move to Kubernetes. So let's take a look at these applications. So if we want to register web and payments into a Consul, we will need to create a service registry. Where is that? There we go. So here we have the second version of the payment service. And I'm actually mounting the service file in here so that it can automatically get registered in the container. Now, that service file contains the actual service registration. So in this case, we're registering a service called payments. It has port 9090, and we're passing in some metadata that we will use later to differentiate. And we're actually specifying that it has a sidecar service, right? And the web service, we're actually already going to move to Kubernetes, as I said. So we're going to be creating, resize this, a deployment for web, and we're going to be passing in some annotations that will actually make that the injector will inject a sidecar proxy for us, and we can configure some things for that. So here we specify that we want to have a sidecar injected. We want to specify that this service of web has an upstream. So in this case, we want to reach the payment service, and we want to reach that on localhost 9090, right? So this is not the actual port where the payment service is listening on, because if we actually go back to the payment service and go to the service, where did I put it? Let me show it here. Oh, it doesn't specify, but it's actually listening on port 9090. So if we would talk to 9091, it actually wouldn't work. The call wouldn't succeed. So we're specifying that we want the upstream to be on port 9091. We're specifying that we want the protocol to be HTTP, and we do this because we want to use the L7 features to actually do some routing for us later. And we're specifying a meta version again. So in the first version, we had a meta version of 1. And in the second one, we have a meta version of 2, right? Now, here we can actually see that fake service accepts environment variables to configure it. So it's easy to use as a demo application. And we are specifying that the upstream URI is actually localhost 9091. And then this, through service discovery, resolves to the payment service. So let's spin this one up so we can use shipyard run v2. So it'll just run everything in that directory. There we go. It's fairly quick. So we can see that the Kubernetes config got applied and that the payment service actually got registered. We're actually applying some extra defaults for the payment service. Since that is not running in Kubernetes, we don't have the automatic configuration of the service protocol. So we need to do that manually instead. So here we have the central configuration of the payment service. So we're specifying that we want it to have a protocol of HTTP, right? And all I'm doing there is actually calling the Consul config write command with that configuration. So that's the way to configure central configuration. Now, if we go back to the UI and we take a look at fake service and we do the call again, we actually see that fake service is still calling this. Oh, where is that? So we needed to go through here instead, right? So what I need to do is I need to get rid of the old one. So we actually only have one instance of the service discovery running because it was now actually splitting over the two. So here we see that we have web running, but we do not have payments yet because I still need to create that. So now we can see that we actually created the payments container. And we now see Consul picking that up and registering the sidecar service for that as well. So it takes a second for that to be alive because Envoy will actually check all its endpoints to make sure that everything is up and running. So now if we do the call, we actually see that web has a very different IP address, which is an IP address from Kubernetes. And then payments is actually still running on the same IP because we had a static IP specified, but we see that it got called with the upstream of localhost on port 9091, right? Okay, so step one is done. If we now move web or payments, this will still work because everything works through service discovery. Okay, so now that we have that, we can then finally move on to actually splitting up our monolithic application. So right now, we have the top situation where if we call any path on web, we actually end up at the payment service that then has IPCs that it calls. In this case, for instance, if we call /currency, it'll do an in-process call to the currency function or module or however the monolithic application is coded. But this currency feature is actually fairly simple, and we can easily take that out of the payment service and turn that into a microservice, right? So that's a great candidate for that. So what we want to do is we want to create a containerized version of the currency v2 and then run that on Kubernetes. And the end situation, what we want to have is that if we call /payments, we still end up at our monolithic application. But if we call /currency, we actually end up at our microservices. And this way we can actually test our application running in the production environment to see if it's behaving the way we want it to. So let's create that. Right. So in order to do that, we need to have our currency service. And I'm going to be applying Kubernetes configuration again against the AKS cluster. And the currency service is, again, using fake service as the internal application. And again, consists of a deployment. So we're creating a deployment for the currency service. We're injecting Consul Connect and the Envoy sidecar proxy. And we're specifying that, again, we want it to be HTTP protocol, so we can actually do some routing and splitting on it later. And it will be running on port 9090, as all our applications have been. So what we then need to do to make sure that we can actually route the request for /currency is we will need to apply what is called a service router. So in this case, if we're trying to resolve the payment service, specified here by the name, with a path of /currency, we want to instead redirect to the currency service instead. So first, let's spin up that currency service. I believe we're at v3. All right, so we're applying Kubernetes configuration. Now, if we take a look here, we now have web and currency running on Kubernetes. So we're starting to modernize our stack. But if we take a look at the calls, nothing will be happening yet. If we call /, we end up at payments. If we call /currency, we're still ending up at the payments. And that's because we have not applied that central configuration yet. So in order to do that, we can do Consul config write, and then v3 Consul service and this router. So we can just write that file. Now, if we would call with /currency, we see that we end up at the currency microservice. And if we call it with anything else, we end up at payments. So all our normal users are not impacted, but the developers and our test users can now test this currency service and make sure that it reacts as we're expecting it to. Okay, nice. So what's the next step? Well, now we want to actually make the payment service call this currency service. So in order to do that, we will need to alter the payment service slightly, so it'll, instead of an IPC, do a remote procedure call to our currency service. And we want to expose that only to our developers. So we'll actually check for the headers of our requests to ensure that they have a header of X group dev included, right? So those requests should end up at the payments v2, which will then call the currency, but all our normal users will still just end up at the payment service. So let's take a look at that configuration, right? So we now have the payment service, and I've already moved it to Kubernetes just to make the coming steps easier. And instead of having the IPC, the payment service now has an upstream, and it has an upstream of currency on localhost 9091, and it calls it here, right? So let's first apply this configuration. So that has created the Kubernetes configuration, but nothing's being routed yet to this new service. We can see that the new payment service is up and running. Everything seems fine. But how do we now route traffic to that service? Well, in order to do that, we will first need to make a distinction between the first version of the payment service and the second one. So that's where these metadata of versions come into play, right? So this new version of payments has v2 specified, and the initial version of payments had a meta version of 1. So what we can then do with that metadata is actually create a service resolver that will actually split those services up into subsets. Because if we would query the service discovery for the payment service, we would actually get both results back. But we want to be able to differentiate between them. So we're creating two subsets, one with v2 that filters on the meta version of 1, and v2 has v2, right? And we're specifying that the default subset is v1. And we do that because we want our current users to still end up at the old version of the application. So let's write this configuration. Okay, so if we then call fake service, we see that we end up at the payment service. Now I'm going to be calling this through curl now, so we can actually add the headers. So if we do a curl for localhost 9090, we can see that first web gets called, then here we have our upstream calls, and we're ending up at the payment service. Now, if I pass in my header of X group dev, we actually still end up at the payment service, but we want to be able to end up at the other version. So what we need to do for that to work is we need to add a payments router. And what that will do is, depending on certain criteria, it'll actually route you to a different destination. So that's the same as what we did before for the currency service, only now we're going to be routing on different arguments. In this case, we're going to match the HTTP headers. And if they exactly match X group dev, we want to route to the service of payments, but now with the additional field of the subset. So now we'll be routing to the subset of v2. So let's apply this configuration. All right, so we just wrote that configuration. Now let's try to call the service again, see that everything's still working. Okay, so we're still ending up at payments. That's good. Now let's try to pass in our group. And we see that we actually get a much longer call chain. And let me pipe this into JQ just so it's a bit more readable. So now we actually see that we're calling web, which then calls payments v2, which then in its turn calls the currency service. So now we have the whole chain of our three applications in there. And we can see that it's being hosted by Envoy. That's the actual proxy that's forwarding the requests. It's coming from Envoy in all of these cases, except the first one, because we're calling that directly on localhost. So cool, now our developers can actually test the new functionality. We can maybe expose it to a test group and get some feedback on how everything is working and make sure that everything is working properly. Okay, so what then is the next step? So now that we're happy with the functionality, we want to be exposing this to our end users, but we want to do that gradually. So we want to slowly introduce this new version to part of our test users. So we're going to be slowly ramping up this traffic from 100% to the old version to 50-50. And then if things go wrong, we can always go back to 100% on the original version. But if things go well, we can then migrate entirely to this new version. So let's see how we can extend this example to actually make that happen. So what we need to do in order for this to happen is we need to specify a service splitter. So this is an addition onto the existing configuration that we've already applied, where we're going to be reusing the subsets that we've defined before of v1 and v2. And we can actually split traffic over those two services. So in this initial case, we want to write this configuration, but still have all the traffic go to our original service. And then we want to split over part of that traffic to the other services, first to 50%. And then eventually we want to move over entirely to the new version. So let's write the first configuration. So we're going to be applying the 100% one. Now I can use the UI again to show this, right? Okay, we're still entirely on the old version, which is great. We didn't break anything yet. Okay, now we should be at 50-50. So if we now do the calls, we actually see that we're splitting between these versions. So part of our users are now getting the new version and other users are getting the old one. If things go wrong, we can immediately roll back if we see anything strange in metrics or alerting. But let's assume everything is working great and we now want to go entirely to the new version. All we have to do is just change the central config. Oh, that'll go the wrong way. And write that configuration. And now we see that all of the calls are going to the new version. Now, the next steps are to split up the next microservice out of the payment service, test that as well, and then roll out each of those continuously and then move those to Kubernetes. And as I showed in the initial example, it doesn't matter if a service is running on a VM or Kubernetes. The service mesh will actually do all that communication for you. So it's a fairly nice way to move your applications and migrate them to Kubernetes or other ways. So if you want to continue learning more about this, there's some next steps. First of all, you can get the URL of this demo. I'll post it in the chat. So you can actually run all of this locally. The only dependencies are Shipyard, which is just CLI, and then Docker to run the examples on. And it'll actually spin up the documentation that you can follow along and do all of these steps yourself with all the commands. If you want to know more about HCS, the public beta blog post is available. These links will also be sent out afterwards. You can go to the Consul Learn website to try out some of these concepts as well and learn how to apply them. Or check out Cody the Arkland's blog series on HCS, which shows a similar workflow to what I've shown you, but in nice videos. So with that, I'll give it over back to Caroline.
Awesome. Thank you so much, Eric. So at this time, we only have one question in our Q&A box that we can answer verbally, and then we can close out for today. So our question is, how can you use Consul with HashiCorp products? Shipyard, Transformers, Packer, using those products to move monolithic applications. Started liking the service mesh that Consul is providing and wanted to know the use cases in tandem with other products.
So I'll just take a PM version of this, and then maybe Eric, you can talk about the mechanics of it. So, from a product direction point of view, one of the things about HashiCorp that's really awesome is that we're moving super, super fast. But also one of the things that's not so awesome is when you're moving that fast, what that means is that not all of our teams are always in lockstep. So the goal here is that things like Terraform and Vault and Consul will be self-supported, and they'll self-supportive? Sorry, that's not actually a word. What I mean is that you'll be able to use them together to solve problems, right? So sequentially you deploy with Consul, and then you put your secrets in Vault, and then you consume with Consul. But I will definitely say that from a product perspective, as a product manager, I think we can do a better job of making sure that joint experience is seamless. And in fact, I was just having a conversation with Robbie and some of the other PM leads about how we go about doing that. So what I would say is that it's absolutely our intent that these products will work seamlessly together. And we think that we have a little bit of work to do there, and we're doing that work. So sorry, Eric, maybe you have more of a practical answer.
Yeah, mostly echoing what you said. I think the integrations between the products are really nice, where, for instance, if you use Nomad as a scheduler, Consul integrates with that seamlessly for service discovery, and having a service mesh then is effortless. Like the integration between Consul and Terraform, that would be, you can provision Consul with Terraform, so you can do central configuration, etc. With Packer, It's all more on the integration side than directly interfacing most of the time. But the integration with Nomad is direct, and yeah, I hope that answers the question. If you have anything more specific that you want to know about the use case, let me know. And I saw there was another question.
Yes, yes, I just saw that come in. The question is, how can I use Consul with multiple AKS clusters on different VNets or subscriptions?
You want me to tackle that one, or do you want to?
Sure. I mean, well, there's two parts to the question. One is the way it works now and the way it's going to work. So just on the product side, just FYI, you know, we have kind of two modes where customers are using this, where some customers have a very tight relationship, a one-to-one relationship between the Consul clusters and the AKS clusters. And some customers prefer to have that as a one-to-many. And the answer is that our intent is to support both modes. But it's definitely a very interesting question. Actually, it's one of the things we'd love to hear back in your beta feedback is how you're planning to use it, how many AKS clusters you want to have, what the relationship is between those. These are all questions that we're asking during the beta period.
Great.
Sorry, I think Eric wanted to say something there.
Yeah, so from a more technical side, the way you could actually facilitate this is by using mesh gateways, which is also a feature of Consul, where you can actually bridge multiple Consul clusters together and basically stretch the service mesh over those two clusters. So you could have a Consul cluster in each of those AKS clusters and then have applications communicate from one side to the other. And I have another demo that I can share the Git repo with that we can maybe send out in email afterwards. That shows exactly that example where you have two Kubernetes clusters that are actually talking to each other. So an application in one side can call one on the other without it actually having to know that it lives in the other cluster.
Great. Okay. So, and then one last question that we just received, and this will be our last one for our Q&A section, is how do we manage multi-cloud subscription models using the HCS account?
Yeah, so the current way that Marketplace works is that a Marketplace object is assigned to one and only one Azure subscription. So inside of Azure, you can't actually share one object across multiple subscriptions. However, as Eric mentioned, you know, the path forward here is through federation, through the gateway model. So you will be able to federate multiple Consul clusters together. This is not in the current beta, but this is an existing Consul feature that we intend to support in HCS as well. So if you have a complex scenario where you have multiple accounts using multiple Consul clusters and you want to create a mesh of meshes, I guess. Is that a word, Eric? I don't think that's a real word. If you want to basically federate multiple Consul implementations together, the idea is that you would use that federation mechanism, and then in effect you would have one distributed environment where the different clusters are talking to each other, and that would be your path to do what you're trying to do there.
Okay, awesome. Well, thank you, Alex and Eric, for answering our Q&A section of our webinar. And thank you to the audience for those questions as well. So at this time, I do want to close out our webinar, and I hope everyone enjoyed today's session and have a better understanding of service networking with HCS on Azure. You can get started today by visiting our HCS on Azure landing page on HashiCorp.com, which will have some different resources linked. You can either also visit the Azure Marketplace listing or our HashiCorp Learn site for step-by-step guides. And finally, as mentioned at the beginning of this webinar, it has been recorded, and we will be making the recording available post-processing. And we'll be sending an email out to all the folks that have registered with the recording link. Thank you, everyone. Have a great day.